All right, IM3 classes. Moving on with our logs, we're going to be talking about the properties of logs. So properties of logs are very similar to the properties of exponents. There's one that we are going to talk about that's slightly different, and that's this first one coming up. It's called the change of base formula. What the change of base formula allows us to do is to evaluate logs in a calculator. Basically, at least that's the most practical application of this, is allowing you to evaluate logs in a calculator that are not base 10. So we talked about this in class. I talked about the last lesson video when it's when you have a log like this with no number for the base, that is log base 10. So all of the calculators, all the logs in the calculator, is just a log button. So they're all log base 10, unless it's an actual log. So it takes an extra step to put in logs other than base 10 into a calculator. And what we can do is called the change of base formula. So if you have log base b of x, you can change the base. You can use the log of any base. It doesn't matter. But it can be log of, so the simplest thing to do is just log base 10. So log of x divided by log of b. So you take this, the log, and you divide them, and that will evaluate, help you evaluate logs that are not perfect bases, or log base 10. Let's actually look at an example here. So we're just rewrite this using change of base formula. Again, we can use any base that we want for the log, but to keep it simple so it matches in a calculator, we're going to just use log base 10, which is just log, no base in there. So log base 10 of x, or this is equal to log base 10 of x divided by log base 10 of y. And that's it. So this one's real simple too. So this is log base 10 of 14 divided by log base 10 of u. All right, and the next one, log base 10 of n divided by log base 10 of b. So real simple to see how to work those out, or to change the base on. So let's see how this works when we actually want to evaluate one. So log base 4 of 44, to evaluate this using the change of base formula, what I'm going to do is log of 44 divided by log of 4. And then I'm going to put that into a calculator. So log of 44 divided by log of 4. Let me switch over to my calculator. Here, so log of 44 divided by log of 4 equals 2.72, that actually rounds to 2.730. Oops, wrong slide. I don't actually need to switch the share. All right. So 2.730. Let's do one more because these are pretty easy. So just rewrite it, change the base. So again, I'm going to use log base 10 because that's what's in the calculator. So log base 10 of 3.6 divided by log base 10 of 4. Again, go to the calculator to evaluate that. So let's switch over to the calculator. So it's going to be log base 10 of 3.6 divided by log base 10 of 4. That comes out to 0.923, so 0.924 rounded. Let me make sure I switch the share. So 0.924. All right, let's move on. We're just skip that last one because I think that's enough. You do the same thing. The actual properties of logs. So you may want to write these down. So pause the video and write them down, or when we're in class, we're going to talk about them. But they're helpful to use. These first two, the product property and quotient property, are pretty similar to those properties of exponents. So if you remember, when you're multiplying with exponents, you you add the exponents together to simplify, or if you're dividing with exponents, you subtract the exponents to simplify. Notice how the expanded version, so we say this is expanding. So log base A of u times v, we can expand that into log base A of u plus log base A of b. So just expanding out into two separate logs. And that's really what we're going to be doing. We're going to be expanding logs, or we're condensing them down. Good skills to have for both. Over here, this is just the natural log. Remember, the natural log is log base E. That E is a constant. That's Euler's number. That is 2.718. But not important if you know the value of E or not for right now. Just know this is log base E. Power property is the one that's different. If you notice what happens with the power property, the exponent, so the exponent, if you have an exponent there, you can move it out in front of the log. So log base A of u to the n, move that exponent out to the front, it becomes n times log base A of u. Let's look at some examples. So we're going to expand these. So log of A times B. You can expand it into two logs, the log of A plus the log of B. All right, here, similar, we used to have 3, u times v times w. We can expand that into 3. So that's going to be log of u plus log of v plus log of w. When we are dividing, you can subtract. So this is going to be log base x minus log, not base x, log of x minus log of y. And then this one, the exponent just gets moved out into the front. So it's going to be 3 times log of x. So those are basic ones, how they work. Let's look at some examples where we're combining all those things into one problem. So first of all, I'm going to expand this. So there's 2. So this is log of z cubed times the square root of x. So I'm going to expand that into 2 logs. So the product is going to be log of z cubed plus the log of the square root of x. All right. And this actually, I'm going to take one more step. That's going to make this a little bit easier for us. There's some Zoom stuff in my way. Here we go. You can remember, you can change square root into a exponent. So the square root of x is the same thing as x to the 1/2. And so here, now the last step to expanding is moving the exponents out front. So it's going to be 3 times the log of z plus 1/2 times the log of x. And that's it on that one. Right. This one's a little tricky. Trying to think of the best way to go about this to make it easy. So first thing I'm going to do is actually take a second to expand on the inside. So this is going to be log of c times cube root of a. So that can be a, actually, we can do all the steps of this so we don't get lost. So cube root of a times cube root of b. All right. So by expanding the a times b into 2 roots, I can see that I have a product of 3 parts here. So it's going to be log of c plus log of the cube root of a. And so I'm going to go ahead and change, since it's the cube root, the 1/3 power. And that's going to help us out the last step. So it's going to be log of b to the 1/3 power. And so then those exponents I can move out front. So log of c plus 1/3 log of a plus 1/3 log of b. Weird way to write a b. All right, here, this one, So this one's a little bit different. A couple different ways to go about this. You can simplify you with the powers here. So that actually might be the easiest thing to do to really fully expand it. So I'm going to use the power of a power property. So remember, this y has an exponent of 1, and each of these gets multiplied by that exponent on the outside. So this is going to be log of x to the 24th times y to the 6th. I think that's probably going to be the easiest way to think about that. And then we can expand that. So that's going to be log of x to the 24th plus log of y to the 6th. And then those exponents can get moved out to the front. So it's 24 log of x plus 6 log of y. Boxes, there's a lot going on this. All right, so for the next one, I'm going to do the same thing. The z and the y both have exponents, so it's going to be log of 5 times 6, so it's going to be x to the 30th times z to the 6th divided by y to the 6th. And so now I'm going to expand that, so it's going to be log of x to the 30th times y to the 30th, so that's going to be plus, oh, excuse me, log of z to the 6th. Since this y is on the bottom, we're dividing by that. I'm going to subtract the log of y to the 6th. And then those exponents get moved out front. So it's 30 log of x plus 6 log of z minus 6 log of y. And that's a weird looking 6. There we go. Yeah. All right, so now let's go the other way where we are going to condense. So instead of expanding, we're going to condense it down into one log. Pay attention, notice that how the log is a different base than just the base 10. So for this, condense it together. So this will be log base 4 of a times b. Condense it down to 1. Subtraction, that means you're going to divide what's in there. And so it's going to be the natural log of a divided by b. This one here, what you're multiplying gets turned into an exponent. So it's going to be log base 4 of x to the 6th. So just condense it down to a single logarithm. Let's look at another example here. I'm going to take this in a couple steps. So first thing I'm going to do is move the coefficients, move those into exponents. So this is going to be log base 2 of x to the 24th plus log base 2 of y squared. And then the last step, I can condense that down into a single log now. So it's going to be log base 2 of x to the 24th times y squared. Yeah, so just take it in steps. This one is pretty similar. I'm going to move the exponents or the coefficients into the exponents. So it's going to be log base 2 of x to the 12th power minus log base 2 of y to the 3rd power. And since we are subtracting, I'm going to, that's going to be dividing. So it's going to be log of 2 x to the 12 divided by y to the 3rd. And there we are down to a single log. Last problem. So remember, this is the same thing as 1/2. So log of z divided by 2 is the same thing as multiplying by 1/2. So you could actually skip this step if you're doing it on your own, but I just want to make sure everybody understands where the 1/2 exponent comes from. That's Dr. Scholl here. So the 1/2, the coefficient there, the 1/2, I'm going to move those into the exponent. So it's b plus log of x to the 1/2 plus log of y to the 1/2. And then I'm going to take one more step, I guess. The 1/2 power is the same thing as the square root. So log of z plus, I'm going to change those 1/2 into the square root. And now condense it all, adding them all. So it's going to be the log of z times the square root of x times the square root of y. It's a single log. And so we actually could be done here. Add all down to a single log. Well, I'm going to take one more step. And if you didn't take this step on a test, I went kind of wrong, but it just makes it look nicer. I'm going to, since these are both in radicals, the same radical, I'm going to combine them under 1. So it's log of z times the square root of x times y. Just looks a little bit cleaner like that. And that will do it for that lesson of all the properties of logs. Next time we're going to be using logs to solve equations. So see you then.